How do lymphoid organs activate lymphocytes? Imagine your immune system as a busy city where tiny soldiers called lymphocytes are always ready to fight invaders. But these soldiers need specific instructions and training to do their job well. That's where lymphoid organs come into play. They act like training grounds and command centers for these immune cells. When pathogens or foreign molecules enter your body, they travel to these organs, which are mainly located in places like lymph nodes, the spleen, and mucosa-associated lymphoid tissues. These organs are packed with special cells that help lymphocytes recognize and respond to threats. Lymphocytes, which include T cells and B cells, circulate through your blood and lymph fluid. When they reach a lymphoid organ, they start scanning for antigens, which are pieces of pathogens or foreign substances. Antigen-presenting cells, such as dendritic cells and macrophages, are the ones that show these antigens to lymphocytes. They do this by capturing the pathogens and displaying fragments of them on their surface using molecules called major histocompatibility complex molecules. This display is like a badge that tells lymphocytes what to look for. T cells, a type of lymphocyte, get activated when their T cell receptors recognize and bind to these antigen major histocompatibility complexes on the antigen-presenting cells. To stay attached firmly, they use adhesion molecules like lymphocyte function-associated antigen when binding to intercellular adhesion molecule 1. Recognition alone isn't enough, though. T cells also need a second signal called a co-stimulatory signal. This is provided when molecules like CD28 on T cells interact with B7 proteins on the antigen-presenting cells. Without this second signal, T cells might become unresponsive or even die, preventing accidental activation. B cells, another type of lymphocyte, recognize antigens directly through their B cell receptors. For full activation, they often need help from helper T cells that have already been activated. These helper T cells provide additional signals and cytokines, which are like messages that tell B cells to grow, divide, and produce antibodies. These antibodies are specific to the invading pathogen, helping to neutralize or destroy it. Inside the lymphoid organs, special stromal cells and follicular dendritic cells create microenvironments that support lymphocyte survival and interactions. They produce chemicals called chemokines and cytokines that attract lymphocytes and antigen-presenting cells to specific areas. During an immune response, germinal centers form within lymphoid follicles. Here, B cells multiply, mutate their antibody genes, and undergo selection to improve their ability to recognize the pathogen. Once activated, lymphocytes multiply rapidly and differentiate into effector cells that fight the infection. Some become memory cells, which stay in your body ready to respond faster if the same pathogen invades again. In short, lymphoid organs activate lymphocytes by providing a place where they can find their specific antigens, receive the necessary signals to become fully active, and then multiply and specialize to fight off infections. These processes are vital for your immune system to work efficiently and keep you healthy.